Good morning, everyone, or good afternoon, good evening, depending on where you are. I believe we are at time, so respect all of you guys showing up. We'll just get started, inshallah. Okay, so we'll get started, and the presentation will be available after for anyone who is interested in information in the slides. My name is Haytham Abou Ftouh. I work as a CTO in a skilled startup. Before that, I was at Lyft, where I was one of the creators of the Flyte project. It's open source now, and it's an incubation project in LFAI and data. Flyte is a workflow automation platform for complex mission critical data and ML processes at scale, and I would underline at scale a few times. But before we talk about Flyte, I would like to talk about why it was built to begin with. Why did we need to build yet another tool? That was about 3 or 4 years ago, and I guess to good analogy to why it was built is a simple question of if you have ever written code or software as a software engineer, when was the last time you lost code because somebody left or quit, or lost their laptop or whatever? And unless you have been coding in the 90s or before, the answer is probably never. And there's a good reason for this, right? This was not the case before. People used to lose code all the time, prototypes and experiments and so on. Even sometimes even production code. But the software industry as a whole got a lot better at introducing these processes, tools, and rigorous best practices that everybody just now take for granted. Git is maybe one of the popular tools for source control, but not the only one. But regardless of which one you use, you have some source control. Even if you are working on toy personal projects, you have GitHub, and lets you create even private repos and others too. So you always have tools at your disposal that ensures your code is safe and it's backed up, and you can always go back to an older version that worked, and so on. Source control is not the only thing, right? You want CI/CD and checks and for deployment of services and so on. Like there is a whole industry, right? This is what we commonly call DevOps, right? You introduce all of these processes to make sure that software developers care or are only concerned about writing the business logic and writing their code, and the rest of the process is or the infrastructure is taken care of. But if I flip that question and ask, if you are an ML practitioner, when was the last time you lost a model because somebody quit, or you lost a model because when you actually needed to tweak it or retrain it, or just realize it's running in production, great, but we don't know where it came from, or you try to rerun it on the same data and you just produce bizarre, weird models, and you have no idea how the old one ever worked. And the answer will change, right? The answer will probably be, last month, last year. For us, that was the trigger for creating Flyte. Models were lost in production, and there was a need. We realized there is a big need at Lyft for a more opinionated platform that takes care of these processes. Flyte is, in a nutshell, has a few tenets that we try to stand behind. First of all is it's an opinionated platform, and what we mean by that is it tries to establish some best practices, some well used methods, and has a good track record borrowed from software industry that we know works. And we try to leverage those and try to make them easy for ML practitioners to use. Second of all, it does not try to reinvent the wheel, right? As I said, why build another tool? There are like a ton of these of tools available for an ML practitioner. Spark, TensorFlow, PyTorch, and SageMaker now, and there are like a lot of these tools that try to give you some structure when you're trying to train a model. So Flyte did not come to replace any of that, but it came to life, I'd say, to connect all of these systems together, to give you some cohesive story, to allow you to interop between systems that are great at what they do individually, but don't necessarily work together that well. Third, it focused on reproducibility, right? One of the very common problems as an ML practitioner would tell us is when you produce a model today, a week later, and you try to reproduce exactly the same model because you want to run some experiment or you want to do something with it, or tweak the data or change something in the code. It's very hard to know the exact code version or the exact piece of code that produced the model you see, oftentimes maybe dependent libraries changed, and that changed results, and so on, right? So you want something that can capture what actually ran and how and what the inputs were and all of that. And Flyte does all of this seamlessly for you. Flyte is also extensible and observable, auditable. And what we mean by that is we realize, right, in any organization, you start with simple use cases. Maybe just my data all fit in memory, and only running XGBoost. I don't need yet another tool to manage that for me. Maybe you start with that and you try to make it very transparent when your use cases are that simple. But oftentimes, this is just the first step, right? You get into more complex use cases. Maybe the data sources change, and you want to introduce checks or expectations for the data when it comes in. And maybe you want to scale and want to run, on multiple machines, or in this cloud provider or that cloud provider. You want to introduce a Spark, piece of code. Right, and Flyte is all the current functionality in Flyte is built using the same extensibility methods that we offer to people. We'll talk about that later. But it's very easy to start adding more and more pieces and provide richer capabilities to others in your organization. And it's observable and auditable. All the actions that happen in Flyte are auditable. All the workflows, everything that runs is observable. You can set alerts. You can put things on schedules. You can watch or monitor the CPU consumption in different pieces of the code and so on. And you get all of this for free. You get all this out of the box. And last but not least, collaboration, right? Oftentimes we see companies start with very tiny ML team. It's just a few people working on a project, and it's very easy to be in one conference room, or one Zoom call these days, and just collaborate on something. But then oftentimes things get bigger. They get split into teams. When you have a team that's only doing data cleanup and data manipulation, or maybe ETL, or so on. There's a different team that does ML or model training and so on. And it gets harder to collaborate between the two. Flyte has some tools that let you, easily work together, share code, or share pieces of code that you both produce, and you can ship independently. So introduce sort of this microservice essence to your existing workflow. To start off, this is our view or our again assumption. Any tool is built with some assumptions in mind. This is where we started. We think this is how people, how ML engineers and practitioners go through the cycle of developing a model. And we have validated that time and time again over 60, 70 teams, different teams at Lyft. So you start with this, I have an idea and I want to try it, right? You start with writing code, on that runs on your laptop. It's just business logic, maybe, I don't know, I want to predict house prices, right around me. And great, so we'll get the data from somewhere, or maybe produce simulated data. I will run some, logic locally, get something out, and maybe I want to run it on a bigger set of data after iterating a couple of times locally, and it doesn't fit on my machine anymore. So go run it somewhere else, right? I want to run on a remote machine. And let's say that worked well and it's great. Now I want to incorporate this piece into a larger piece where, I get the data from the real data set, run this thing, and maybe run some predictions or tests or validations or whatever after. It's what we call a workflow, right? And you keep going into this cycle until you're happy with that, workflow you built or pipeline. Then you say, okay, and let's ship this. Oftentimes we see people without a tool like Flyte, these two worlds are completely different. On the one hand, you have maybe it ends up being a Jupyter notebook that's has all the logic in there, and then they ship it to somebody else to take care of productionizing it, and that takes weeks to do in certain companies, in certain situations, maybe months even. But in conception, all you want is, I wrote the thing, I know it works, I want to take it to production, I want to run it on a schedule or run it regularly when data changes, I want to set up alerts on it or detect when data drifts or and stop shipping to production or things like that. Then maybe it's working great for a few months. Then later you get an alert that data drift has happened and we stopped shipping, and the system automatically stopped pushing the new models to production because of this. And you want to investigate, right? And you make it very easy to pull an execution that you want to look into for whatever reason. Maybe it failed, or maybe some dependencies changed or something like that. You can pull that execution, investigate, look at the data, intermediate data produced, and so on, and then you can repeat the whole cycle again. So we think this is this conceptually what people want to do, and Flyte, it tries to most of the time just get out of your way and just let you do these without thinking about well, how do I package this, or how do I make sure that the thing I run remotely, nobody would accidentally run in production, all of these things, or how do I scale the thing that runs on my machine to hundreds or thousands of machines, and do I need to code things specially or write, use different libraries to do, sort of map, multi-machine map jobs? Do I need to convert things to Spark because running in on one region or one city for house price predictions, is, while that fits on a machine running all across the US or anywhere, does not. So now I need to parallelize it somehow. Do I need to switch how I'm writing it to be able to parallelize, right? So tries to get out of your way, and just let you focus on that business logic. So let's dig into how Flyte allows you to do all of these things. And just a few concepts to begin with to set the stage. Flyte has a concept of projects and domains. And projects we think of as a logical entity that you can use to group the execution pieces, the workflows and tasks, and so on. You can use projects any way you want. You can map a project to a team, or map a project to a certain model or a problem in your organization, or a repo. It's up to you how what it maps to. Within any project, there are a set of what we call domain. These are like execution scopes. What we commonly use them, the most common ones we see are development and production. These are customizable as well, but people use them as sort of a CI/CD system, right? While developing your workflows and tasks, you only register them to the development or run them in the development scope. Maybe you have, from your infra team, you have different SLAs and so on for development and production. But at least they're completely isolated. You can have different permissions, infrastructure-wise permissions between the two. You can run in completely different clusters and so on. And then you use sort of CI/CD system to promote things from development to production when you think they're ready. And within those is where workflows and tasks come into the picture. And I think it's worth taking a moment for. This is one of the, I would say, the strongest not features, but more of concepts that differentiates Flyte from other similar platforms. So tasks and workflows in Flyte are declarative, right? We use protobuf. It's if you're not familiar with protobuf, it's a Google open source project that is concerned about declaratively describing data classes in a language agnostic way, and then it has a ton of tools that generate language-specific libraries, right, to be able to use these data classes. And the appeal is that the wire format, like whenever you serialize any of these objects in any language, they look exactly the same over the wire, and you can deserialize them in other language. And we leverage this very heavily to be able to interop between different languages. We wrote a Flyte kit in Flyte kit is our SDK in Python. We did that 3 years ago. Spotify, when they onboarded on the platform, they were a very heavy Java shop. So they wrote a different SDK in Java, and they didn't have to touch the system at all, right? Or modify or put any code that says, if Java do this. It's only a client-side, library that again uses the same protobuf generated classes to produce the same wire format, and you can then write some tasks in Java, some tasks in workflows. You can write some tasks in Python, and you can describe the workflow in either, and you get full interop that way. And second of all, Flyte is typed, strongly typed. So when you have a task or a workflow, all the entities in Flyte have typed interfaces. So you have to declare that this task expects, these maybe an input and a float, or this task expects a schema of these columns with these types and so on, and will produce that, maybe a model or a blob of data or something, or blob of data of certain format. And we use this information to statically verify the graph, like the workflow graph, to tell you that, this Spark task will fit into this subsequent task, or maybe not. And we'll get failures that way, like compile time failures very early on. So once it compiles, you know at least data passing between these pieces will work. Individual pieces might still fail because the actual data expectations are not met. But this is where some of these extensions come in, and we'll talk about that in a bit. Workflows are the sort of the Uber point, the Uber concept on top of tasks that lets you declare the flow of data between these entities. So you can say, take the data from this task, the output of this task, pass it to this task. But not only that, right? You can also compose workflows of other workflows. I was talking earlier about certain like teams that work on maybe ETL jobs or teams that do ML. They can each have their own set of workflows, and then you can have like a driver workflow on top that calls or orchestrates these workflows and pass data between them. Workflows are also can be dynamic, so you can. It's a very popular feature, I must say. It allows you to, at runtime, to execute, a piece of code, again, as part of a bigger graph that says, well, I now looked at the inputs, the actual inputs, and realized that I have to run this as a map task. Right? I can't fit this in one machine. I have to run it in, 100 or 1,000 or 10,000 machines. So it can do that at runtime, and then the right. So like at runtime, let's say this top level task realize that, and then it can sort of spawn another smaller graph that does this thing. It can be completely different workflow that does whatever it needs to do for this kind of input, and then come back again with the same expectation that it will still produce an internet schema overall. So it allows you to modify the DAG at runtime, and it's very popular when you can only do so much or have so much assumptions about the data that will come in, but then you discover other information, other size or the actual size of the data and so on at runtime. Last thing, I was saying there is a decel, like a domain-specific language that we wrote in Python, but Spotify wrote a Java one, and it's donated under the same project. But you can also write others, and one of our current customers of Flyte has written a decel, a very specific decel for their company, for their feature teams. That allows them to declare, certain queries or schedule and orchestrate queries in certain way. Again, this was only a client-side change that offered this decel to their customers. And there are tools and like libraries within Flyte that allows you to make this even easier. Another concept, I touched on this a little bit, is Flyte comes with native support for map or array jobs. These are map style tasks where you say, I have this large input or like an array of tuples, and I want to run the number of jobs on it as big as that array. You don't have to learn how to use AWS Batch to do this, or have to rewrite your code to use Spark to do this. Right, it comes natively with Flyte, and you will see in one of the examples it's even it looks like you're just writing a single-threaded Python program, and magic happens when you run it remotely. All right, dynamism, we talked about that. It allows you to modify the graph at runtime to based on the input. Based maybe on the size of the input or the shape of the input or maybe the schema after you look at it or sample of the schema, you can decide how do you want to process that input. Another very popular concept, another very popular feature in Flyte is something called data catalog. It ships as a separate, it's a standalone service. You can use it as a standalone service, but it offers very attractive, I guess, features. It adds very attractive features on top of Flyte, lineage and memoization. We'll talk about each So lineage, what we mean by that is allowing you to track by maybe looking at the final result, maybe looking at a model that was produced or shipped to production, all the way back to the data that was used to produce this model, maybe through the ETL job and through the model training job and through the schedule that ran and so on, right? You can tie all of these together as long as you are using Flyte, to do all the orchestration. It can go all the way back to the table that was originally used to train this final model. And it's very huge to allow you to debug and make decisions or tweak data based on the actual models running in production. Memorization is what we mean by memorization is allowing you to not rerun the same tasks over and over again for the same inputs. So if you have a task that maybe generate data for you, right? So there's no, in a lot of cases, right, there's no point in rerunning that and just regenerating the same data over and over again. Maybe querying data by certain date range, right? So the task takes, the date range and just queries that certain table, give you back the results, and then move on to the next task. If you are following, again, the same best practices, querying the same date range should produce the same results, right? It should be a very deterministic output for that task. So you can mark it as such. You can say, I know this task is is cacheable, and that will automatically, when the task runs, will cache the outputs or a reference to the output that this task produced. And if it's called again with the same inputs, it will just fast forward to the next task. It makes your even iteration speed that much better when you do that, because then you can focus on the task that you're actually developing, and it's a general best practice to code your tasks that way, not have them do side effects or consume inputs that are acquired externally. That everything should be described in the function signature, and this is this is just functional programming concepts that just Flyte encourages people to use. Workflows and tasks in Flyte are reusable, and you can share some of the common pieces across teams without having to share code or coordinate the dependencies, library dependencies, and they have to all be on the same version for these things to work and so on. Because Flyte everything that runs in Flyte is containerized, or the code that runs is containerized. You can, once you declare the interface on top of that container, you can share that artifact or the task declaration with other teams or workflows, and they can just invoke them. Allows you to, if you have a team that does maybe the ETL pipeline, and they have a model that does produce certain tables, you can just invoke that, and you don't have to know exactly where, what libraries it uses or what it runs, or even how it runs. You're just calling it as a sort of a microservice, but it's all within the systems. It's all tracked. It's all observable, and so on. That allows that other team to ship things independently and keep improving things without having to coordinate these. So with that, these are the top, I would say, highlights of the concepts and features in Flyte. There are a lot more details, obviously. I'll be happy to answer any questions. If you have any, you can post them, you can start writing them on the chat. I'll move on now to give you sort of an overview on the Flyte system, and then we can gloss over some of the infra details and talk about how you can use Flyte in your existing workflow, and then we can look at a demo for starting one. So at the top level, at a high level, there are three pieces in Flyte. There's a user plane, there's a Flyte, the backend system, and then you have the execution engines that actually run your code or queries and so on. On the left, there is the user plane, and there's some a stick person there that will write code, right? So this is the top box there. They can write just tasks and workflows in Python or some language. They can leverage Flyte plugins, the Flyte Kit plugin, like client-side plugins, to extend what they can do there. They can have their own custom DSL and so on. Then they would use a normal GitOps flow, right? So you like maybe check in code, push it to PR, whatnot, if you want to, and Flyte integrates well with those. But even if you don't, you can run things locally, right? And this is that UI you can see here. You can have this UI, you can have the entire system running in one container locally, so you can interact with it and do the whole experimentation, everything locally. Once you're happy with this, you can then start shipping things to maybe a PR and maybe to your production cluster and so on. And lastly, you can use like a terminal, like programmatically talk to other CLIs that allow you to talk to the same backend, offer similar functionality, in some cases more than the UI does, that allow you to interact with the backend to retrieve results or submit or executions, start new executions, and so on. And you can programmatically also do that, and we have seen people do that at Lyft, building like some custom UI, web UI for their own, either their own platform or their own team, that allows certain functionality that's like domain specific. And the thing that makes it all happen is this layer of protobuf and gRPC. So regardless of how you came into the system, right, you're writing Python code or doing Git operations or doing a UI or using CLI tools, everything just gets into this protobuf gRPC serialized wire format standard that then comes into the middle box, what I call Flyte system, and comprises of a few microservice architecture that currently runs on Kubernetes, can be split elsewhere depending on your infrastructure, and comes with dependencies on your cloud provider. Infrastructure pieces. It needs a DB, it needs a storage, and queuing service, scheduler, and so on. And we have Helm charts and so on that lets you run on GCP or AWS, and we are hoping others will also introduce other cloud provider Helm values, allow us to run everywhere. It can run, of course, locally on like a kind cluster or local clusters. And then finally, on the right side, you have execution engines. And these are the tools that actually run your code. As I said, Flyte does not try to replace any of these tools. It's just there to make it easier and better, enforce and encourage best practices in how to use these tools and introduce interop between them. So it comes with a few plugins already, right? You can call Spark, you can call SageMaker, Batch, Estina, you can run queries and so on. But you can, I think, you can build that box is already wrong or outdated. A lot more that were added, and people can keep adding more plugins here. It's a very strong interface, and all the built-in plugins are also built the same way. It allows it's a very extensible system that way. And for the purpose of this presentation, we'll only focus on the left side here, which is the user plane. How do you interact with the system? And it offers mainly three pieces. There's the SDK, and that's where you write your business logic in Python, Java, or others. You can enforce and validate the typing, and the things fit. You can run everything locally, just like you do in Python, so single process and so on. And you can also compile it into protobuf, the Flyte ideal format, and run it on a local cluster or a remote cluster exactly the same way. Of course, the main difference being, your local machine can only have so much memory. Remotely, you can run on thousands of machines, and you can parallelize things that way. Then there's the Flyte console, the UI, where you can launch, monitor things, and then the Flyte CTL is our command line tool, and allows you to do to interact with the backends and do GitOps style jobs. You can put it in your CI system to every on PR, serialize and register these workflows and maybe even run them and validate that they complete successfully or that the results are comparable to the old execution results and so on. We'll talk about how do you then start about writing a workflow? How do you get from I wrote a workflow locally into to all the way to running it in a remote system? And this starts with a process what we call registration. So you start with you wrote some piece of code, function that just says hello with a name, another function that calls it with a couple of values, which is just a simple oversimplified representation of a workflow of sorts that you can run locally, and you can run this with just Python, right? And then you declare them, you add these declarations, add task and workflow, and that gives you that tells Flyte that this is how you want to slice your code, right? A workflow tells Flyte that you describe the data flow between other entities here, so it can be safely statically compiled. And a task tells us that this is an execution unit that you want to run as one entity, potentially on a separate machine. At this point, nothing really has changed. You can still run this locally, right, in Python, in single process, and these tags will mostly be ignored, with the exception that Flyte will now start, the Flyte kit part will start validating that you are passing the right types when you call functions before even invoking the functions, as opposed to Python, just using these as type hints. And once you have, you're happy with the local run of this, maybe you need to run it remotely because, again, of the memory restrictions and such. You can build a Docker container. This is how we recommend people package their code. The reasons that are independent of Flyte, right? Docker containerizing your code offers a way offers a way to reproduce the results from that container consistently, or passing it a lot around and shipping it to others and so on, and making sure that they run exactly the same code with the same dependency, the same native dependency, and so on that you originally wrote. So you package your code in a Docker container, and then you do what we call a serialize on it, right? And at this stage, it's where it statically runs your workflows, the things you declare with @workflow, and produce these declarations of what the tasks are in the system, their interfaces, what inputs and outputs they expect and produce. Same for workflows and what data flow, how the data flow happens within tasks in a workflow, and so on. And then you ship all of this. This is the registration part. You ship all of this to our backend service, and where it keeps things in an immutable store. So if you register, so everything is versioned and everything is immutable. If you change the code or change dependencies or change the container, you have to register a new version. We recommend people just use the git cha as your version number. This way you can easily tie a registered entity with the codes commit that produced it, but you're not restricted to that. You've also seen people use some semantic versioning when they register things through CI systems. There is a slightly different process if Docker build is not as optimized in your environment as it needs to be, or because of the the native pools, native dependencies pool, and so on. This process is what we call fast serialize, fast register. In this process, you started with, you built the container once, right? It has your native dependencies and maybe Python dependencies. But what we noticed that most of the time, those don't change that often. What changes more often is your actual code, right? You tweak the tasks, you add logs, log lines, and so on. And you don't need to rebuild the Docker container for that. You can just do this process which tars and stores the code in some remote storage. And then the rest of the process is very similar, right? It serializes again the new ones and registers the new ones. And the system knows how to pull that tar file at runtime and run it instead of the existing code in that container. At runtime, this is just demonstrating how things happen. You start from kicking off an execution through CLI or UI or a gRPC code, or maybe a schedule. It goes to Flyte admin, goes to a cluster, execution cluster based on some execution, some routing rules. In Flyte admin, maybe it will say, development domain goes to this development cluster where we, have the latest versions of everything, but it's less stable, maybe has more resources and so on. And it comes to the cluster, which then gets picked up by our execution engine, is what we call Propeller, and it traverses the graph and figures out what needs to happen and so on. And it runs as sort of a state machine, right? Because you have a DAG. Not all the tasks can run at once, so it will figure out the ones that can run initially, run those, wait for them to finish, and then move on to the next ones and so on, and tries to parallelize your work as much as possible. And as it's running, right, it keeps feeding back information to Flyte admin about the status of these executions. So you can always update the UI. You can always see in the UI what the status of an intermediate step is, and so on. We can talk about these deployment models if somebody's interested later on, but for now I will skip over those just to say that, there are different ways you can deploy the system in production, but as I said earlier, everything can run locally. Flyte also comes with dashboards that give you information at a glance about the system, like the infrastructure pieces, the services, and so on. But also, I think maybe even more importantly, dashboards about the user workflows. So you can get these Grafana, if you're not familiar with that UI. We have these dashboards. They're open sourced as well, that give you, information about how much memory a task took in CPU in a workflow, how the success rate of these tasks and workflows, things like that, right? So how much weight did the task have to have, maybe because of infrastructure, resource limits and so on. So it gives you, all of this information, and you can scope it down to this particular workflow or a project and so on. Can be very useful to debug, to understand the performance of the system, and also always improve it. Or you can use it for cost analysis, which also we have done at Lyft, to understand and optimize cost for workflows that maybe don't need to run as often, or maybe can run with less resources because they ask for more resources than they consume, and so on. From an ML practitioner standpoint, the UI offers also great. It tries to be a great place where you can, at a glance, know what has happened. Right? If something fails, we pull a call stack and logs right in the UI, so you don't have to go fiddle around and figure out, where the logs are and so on. But if you do, there is this, view logs link. We also have a pluggable way to link you directly to the logs that were produced by this container. whether that's still running in Kubernetes, right, if they are still around. But we know Kubernetes logs, disappear as soon as a pod disappears. So what we have seen people do is they push these logs, right? They have some system, maybe Elasticsearch or something. They push all of the logs to a different system, or stack driver if you're a GCP shop. And we have plugins for all of those, so you can always in the UI click a link and just go to the scoped filter for this task to see the logs. Extensibility. So this is where you teach Flyte some new tricks. And there are a few ways how to do that. There are a few extensibility points, and that were like deliberately set in certain places to offer great modularity and extensibility, but also be very safe for the rest of the system. Go over them quickly. In FlyteKit, you can start with this. You can start with a FlyteKit type transformer, right? So there is a type system. We'll do a talk about that in the open source meeting next Tuesday to go into deeper into the type system. But in essence, Flyte has a type system to be able to declare types in protobuf format. Again, language agnostic. It's very extensible, but also very rigid in certain cases. And FlyteKit has a way to transform Python types into those protobuf types, and it's a very good extensibility or hook for you to be able to add additional functionality in those type transformers. So you can say, for example, if I get a data schema, right, so data frame, I expect, maybe you have a great expectations or Pandera extension. There is an existing Pandera extension that allows you to set expectations and validation rules on the incoming data. So you can say, I do get an accepted data frame, but I expect, to have these certain columns or certain value ranges for these columns. So you can describe all of that, and the system will automatically run those as it's like unmarshalling or reading the data as you start consuming them. Same thing for producing, right? So you can maybe convert a certain new data class or new type you create to a map or some other transformers that way. There are also FlyteKit, what we call FlyteKit only plugins, right? So these are plugins that you can completely write in FlyteKit without touching the system, the backend system, and they offer ways for you to standardize and package how to execute certain tasks in a familiar environment, right? So one of the popular examples here is running SQLite. So we wrote a SQLite container it's generic, right? It doesn't know where the database is or what the query is, right? It just takes the query and run it. And then you can use it, you can share it with others that way. You can share it, it gets shipped to this FlyteKit plugins prefix, right, in PyPy. People can install it and they can start running queries that way. And it will look from, we can look at some examples there. It will look from a user standpoint, just like other backend plugins. And it might be an easy way for people to get started that way, to write plugins as, FlyteKit only task plugins first. And if they see a lot of usage, they can move them to backend plugins. And there are benefits in doing that, things like, resource tracking, resource constraints, and managing, parallel executions and so on that you can do in a backend you can't yet do in FlyteKit plugins, but it's definitely the barrier to entry is way less when you start with these plugins. You can also, while you are in FlyteKit, you can write your own DSL, and there are tools in FlyteKit that allow you to make this easy. But this is one way if you are comfortable writing the DSL in Python. What Spotify did for the Java is they went straight to the protobuf, right? So we wrote everything in Java that serializes into protobuf format, and either one works. You can leverage this to customize Flyte even further for your own use case without compromising the shareability and extensibility across teams, right? So you can do it. You can do this a specific DCL for your own team, but the task and workflows produced that way can still interrupt with tasks and workflows produced from a team working in Scala or writing Java, Spark, or others. And then backend plugins. And this is where we offer controlled extensibility. It runs highly trusted code in the backend alongside Flyte backend pieces, and allows you to offer microservice, if you will, architecture when it comes to deploying and iterating on these without interfering or without affecting, without asking people to migrate and so on. And it offers a way to extend where and how things run in a very generic way. The only interface between those plugins in the system is sort of a state machine that we run, so we can keep pinging the plugin, say, well, run this thing or start executing this thing, and what's the status, and so on, and offers things for the plugin to store the state in a sandbox and make sure no two tasks can corrupt the states for each other and so on. So there are like tools around this, but it's a very, again, highly trusted code. You don't want to just consume plugins because they can affect the stability of the system. But when you have, but it offers great extensibility to the execution engines. All right. I thought I will pause for a minute to take questions before jumping to a demo. We don't have any, but yeah, anybody has questions they want to ask? All right, you can post questions to the questions tab here for anybody who just joined. We're talking about Flyte, and we will go into a demo now for how to run Flyte and what to expect. And the example we use here is what I started with, the house price prediction. It's a very popular topic in the US if you are following the news. Switching gears to PyCharm. So we wrote this workflow and a few tasks that just show as an example how do you write one. What it does is we can start with the workflow. It generates data, right? So this is all simulated data. You can obviously replace this with the thing that actually pull data from some real data source, and it splits the data to training, validation, and testing. Then it runs an XGBoost model on top, and then it generates predictions for using that model for the test data. And then you get back the predictions, right? So this is, I hope, is a very straightforward workflow. And as I was saying earlier, right, doesn't even have to be a workflow. Like if all of these are just regular Python functions, you just call them the same way, right? You have an interface, you have types, right? Data frames or our own Flyte file type. This can also be the default IO streams. And then you have the final outputs. It's a list of floats, right? This is I would say, if you're not used to adding type hints in your functions, that might be the only thing you will have to do, to go out of your way to add. Otherwise, it's just Python functions, and you can run them. Let's show the terminal here. Yeah, so you can just kick off, and all of this does is call the function, right? You can run this, and yeah, see, it doesn't produce that many data, so it runs very quickly and produce results for the region I like presumably generating data for. Let's say you started doing this and you realize for the region you are running data for the model for, the data is too big, you can't fit in your machine, and this is where you start giving these hints to Flyte and say, okay, this is where I declare the data flow between things, and these are my units of execution. I want to be able to run the predict task independently. It has these, this memory requirement. It's cacheable, so make sure if I get called again to predict the same things, well, I should produce the same thing, right? For the same model and the same test data set. So Flyte will just take care of caching this and not executing your code again and again for the same inputs. Same thing for the fit function, right? For the model, if I am training the same on the same data with the same validation data in the same location, right? I should produce the same model, and I do realize not many algorithms would produce the actual same model, but that's more or less the expectation, that the model will perform the same way if given the same input data. So this just shortcuts that and say, well, actually do return the same model, the same exact model. And again, you can say, well, this one needs maybe more memory or more CPU, and you can have different resource requirements that way. Right, and finally, this task is what in this example generates the data and then splits the data set into 3 data sets. Right, this is all I needed to add, right? Like the add task and add workflow. And again, if you run it locally, runs exactly the same way. It produces extra output that Flyte produce to tell you what was sent to which function when it was invoked and so on. Once you're happy with the results, right, you can say I want to then run it in a more remotely in a bigger cluster with maybe more memory and so on. And this is where you can register, go through the registration flow I was talking about earlier. Let me open the terminal here. And it comes, there is this Flyte Snacks is a repo full of demos in all sorts of things. I would encourage you to look at. It comes with a sandbox cluster, what we call it, right? This make start command will fail because I have already done it. It will, so if you do docker ps, you see this one container. It's a Flyte sandbox. That's running, that has the Flyte system in one machine, in one container running, and it gives you this nice UI. Hold on, let's go back. Yeah, it gives you this UI where you can explore, interact with the system, and it's pretty much what you get in a production environment as well, just running on your machine. I went ahead and registered these workflows. Again, there's a one line command that will take care of that for you. And I have my workflow here. I kicked it off. You can launch it. Flyte will automatically generate an input form for you based on the input types, and you can launch that. And this is what you get, right? When things execute, fine. You get successful executions. You have a graph view that shows the relationship between nodes or the data flow between these nodes. And for any nodes, you can see what the inputs were and the outputs it produced. For example, this is the generate and split It takes, this simulation numbers, how big, how many houses you need, and so on, and produce 3 data sets. For the fit, it produced a model with the, as you see, this is what we call an offloaded type. So these data, the actual model is not sent or not tracked by Flyte, but just a reference to it. So it's very cheap to pass that model around between different tasks because all it's passing is this string. But you can see in the URL here, this is say a specially crafted URL. So it's what we call a sandboxed data, again, following the same concept of immutability and versioning. This file will not be touched again, right, by the system. It's produced, written once, and can be reused, like consumed by any number of tasks, even subsequent executions of the same workflow, but it will not be overwritten. So you can always guarantee that if I rerun this workflow, it will produce the same file because everything is cached in this case. There is a little icon here that says, hey, this was the first time we actually ran this task, and we wrote the output of the task to the cache. So next time if I run, it will not actually run the code again. Same thing for predict. It takes the model that was produced in the test data set and produce predictions. You have a link here that takes you to the logs. If this thing fails. In local cluster, you only get the Kubernetes logs, but in production, you can have CloudWatch, Stackdriver, or Splunk logs. You can have any other log links here. We have also, we do that too for backend plugins, other plugin plugins that don't just have logs. For example, if you're running a query in Athena, Presto query and so on, you can have a link here that takes you to the Athena dashboard in AWS or whatever the execution engine is to look at the more information about the execution. If it's a Spark job, you get links for the Spark driver logs separate from the user logs. You get the link to the Spark dashboard, the Spark UI, or a Spark history server if the execution finished. Right, so you get a lot more information with the depending on the different plugins that were used to launch this. You can see here also it says attempt 1 because it successfully ran. It will not run again, but you can specify retries, and they will all be tracked here. You can also always look at the the logs for the first attempt and so on. Let's see. Yeah. So this is all great, right? It's working fine. I can relaunch it here to see the the memoization in action. It starts with this unknown phase. Then the system picks it up, and as soon as it does, you can see it's almost right. Everything is done because it took 6 seconds to finish. This is because it didn't really run any code. Everything was already cached, and we just reused all the outputs, right, all across. And if you add one more task here, then in that execution, only that one task will run. And this is all, right, all fine. Even when it ran, it only took 15 seconds, but it took even less when it was cached. Now the power comes in when you want to take this one model and want to do it or replicate it for maybe 100 or 1,000 cities across the country, maybe or different regions, or maybe all across the world. You want exactly the same code, right? There's nothing you would want to change about it, but you don't know. I guess one of the things you don't know is maybe one city will have a lot more houses to predict prices for than others. I don't know how many cities I will run on. I don't know if the data set for that city will fit in my memory. And this is where dynamism come into play and array jobs. I have another example here that I would like to show. I think I'll have to exit this. And yeah, go here, presentation again. Right, so this is another example. again, all of these are available in Flyte Snacks repo. That does pretty much the same thing, except that it's generating data for multi-regions, right? So you get list of locations, not a single location, and it produces data for each location. So you get like multiple. You can look at the interface on that task. It will produce data sets for each of these locations. You can see here that I did not declare this as just a task, right? Because it's no longer just a task. I don't know, why when I wrote this, how many locations I will be asked to produce data for. It could be 1, could be 100,000, and maybe I will not be able to fit all of them in memory or write all of them, on disk locally. So what this tells Flyte is I want to run this, and this, when it runs, it will not actually produce the data. It will only describe what to run or the modifications I want to happen on the graph in order to produce the data. The code looks, I hope, straightforward, right? It goes over the locations, right? There's no parallel for or anything, right? This is just a normal like Python for loop. And then it calls generate and split data, which is the task we used earlier, right? So this is declared as a task. It gets back the results for that one location, and then appends them to the outputs, right? So if you run this locally, with 10 locations, it will call this function 10 times, get the results, and you get back 10 data sets for each of the locations. But when you run it in a remote server with this add dynamic, it will not actually call this task. What will say, oh, you want to call the task? Great, I will record that fact. And this is the outputs you want to like consume. This is how you want to use those outputs, right? So you're essentially describing a new workflow at that point in here, right? And then this is how you want to like return the outputs. I can call other tasks here too. If you have, I don't know, you get maybe some validation on right on the data set. I don't have that function actually, but yeah, you get the idea, right? I can call other functions here that consume the data, right? So I'm describing a full new graph here, and at runtime, right? We will run this once, find out what that new graph is, then Flyte will go run that graph independently. It will scale on its own, right? It can run between, if you have just one, it will just run one. If you have 100,000, it can create 100,000 containers. They can run with the different resources and so on. And then the final outputs will again be that collection of data sets. So with this just one change, I am now able to produce data for arbitrary number of locations at with the same, but guaranteeing the same strong typing and so on. Then I have a parallel fit function and predict, which again is a dynamic workflow for the same reason, right? You don't know how big or how many locations you will need, and it does a for loop, a regular Python for loop, once again, that does a fit and a predict for each of the locations. As I said earlier, this will not actually run the first time you call this function, right? This will just describe what needs to run, like the execution spec, the graph, the workflow that needs to run. And once it's, once the execution here is done, it will then actually, parallelize and run that execution as fast as it can across different machines and so on, give you back the results that you expect. So all throughout this exercise, right, you are just writing Python code that you can fully run and test locally and validate that, that I'm zipping the right things and I'm passing the right value. You do all of this, right? I've seen other tools that like force you to use maybe their own for structure and or their own parallel structure, and then they have to be careful about implementing that locally. Otherwise, you don't get the to test it locally. You only test it when you run it in a remote cluster and so on. So we find that, again, getting out of your way, letting you just focus on writing your logic, a very powerful and very big motivator to follow the best practices. And there is, like, throughout this, right, it took a lot of thinking and iterations and tweaking to get to a point where we can say, well, we don't need you as a network practitioner to change the way you think of the logic of training and so on from a single process to this passively parallel system. You just have to follow good practices for writing code in general, and Flyte takes care of the rest of all the infrastructure needs. Similar to these regular tasks, you can write a Spark task here, right? So this can be maybe your fitting is a task with a Spark config, that will allow you to run this as a Spark job when you get the Spark actions in their own what's it called? Not RDS. I forgot what it's called. So their own notion of a directed graph, and you can fully use Spark that way. Again, you can run it locally with PySpark, and it will look just like a Python function with PySpark, or you can run it remotely, and remotely Flyte will take care of starting a Spark cluster for you, an ephemeral Spark cluster, run your tasks with the data and so on, get the results, and then move on, take care of serializing this, marshalling the data between tasks. I don't have to worry about how do I consume the data I got from Presto into a Spark task. I'm not, right? Like Flyte will take care of all of that grunt work, if you will. And I have taken the liberty of running this beforehand. It failed once because I did not have the right Docker images. So you can see, in this workflow, there were only two nodes, right? There is the generate that produced data for each of the locations. I think there are 10 of them. It produced, the test and train and so on. And then this is doing the parallel fit and predict. If you see here, there is a little arrow that can, if you expand, it will show you the individual runs that were produced for each of the iterations in that loop. So again, Flyte understood that you're doing this dynamic workflow. You have an arbitrary number of iterations in the loop, so we execute that, and it will discover what needs to run and run it independently. So each one of these produced its own tasks and its own codes, and it's given a specific train and validation for one location, and it produced predictions for that one location. Sorry, produce a model for that one location. I think we don't collect the actual prediction in this, but that's all right. Yeah, so I think with that, I can keep showing you some other features in the UI if people are interested, but I think I will stop sharing for a second and open up the discussion. So we'll start with a question from Akshay. I apologize if I am mispronouncing it. Sorry if I missed this earlier, but can tasks in a single flow run on different execution engines? Excellent question. Yes, the answer is absolutely yes. I have have this one slide in the end of the presentation that says, for Q&A, the answer is probably yes, but ask anyway. I love the question, yes. So yes, Flyte tasks can be completely arbitrary in how they run, where they run, and what they do. The only strong requirement is having a consistent interface and adhering to that interface. So you can have one task that maybe run a SQL query that produce data, data frame or data like in CSV or JSON format or whatever. You can have a subsequent task that run a Spark job, right? It runs completely different environment, produce models maybe or something, or maybe additional data. You can have a subsequent task that maybe call an API service to publish a model. Right? You can have tasks doing completely arbitrary things. And in all of these, the reason for having these plugins is to make sure that the marshalling and saving of data happens correctly across tasks, so that we can pass data between tasks in a very consistent and predictable way, without, again, users having to worry about how to run these systems, and how maybe some systems have different requirements for how the format of the data and so on, right? So Flyte takes care of all of that. I hope that answers the question. Please let me know if it doesn't. I'm happy to dwell further. Andrew is asking, I had to step away for a second, so apologies if you already mentioned this. Do you support distributed training? Yes, absolutely. So again, I will, you might have missed this, and it's okay. Flyte does not try to replace any of the tools you already have that are doing excellent job at certain things. For example, there is a PyTorch distributed systems in different execution engines, one of them in Kubernetes. So there's a similar one for TensorFlow. So there is a team that's maintaining a TensorFlow operator and a PyTorch operator, separate teams, obviously, that lets you do distributed training. Or maybe on SageMaker, same thing, right? Flyte does not try to put you to replace them, but what it does for you is being able to invoke these completely different systems from a consistent interface, right? So again, going back to Shai's question, you can get the data from a Presto query, right? Maybe run some transform on it, and then run. And you only want to run on a PyTorch distributed operator in Kubernetes, right? From a user code, and I think we might have an example on that. I will try to pull it up. You are just writing, again, coordinating Python functions and so on, and writing your business logic. You tell Flyte that, yes, this is a distributed PyTorch function, this is a Spark function, and then that will let Flyte know which plugin, what's the right plugin to invoke to do the right thing. But yes, this completely works. We have support for PyTorch, TensorFlow, SageMaker, distributed training for all, and others can add through other plugins as well. CET, how does Flyte resolve PIP requirements? Excellent question. So we do not, I think, is the short answer. One of the very early decisions we took, it was, I don't know, 4 or 5 years ago, was to rely on containerization. So we do not try to run, 2 different tasks or workflows or a task produced by this team and that team in the same Python environment. Will do, Andrew. In the same Python environment, right? Because we know this can produce issues. We know other tools have tried this. We ourselves have tried this with Airflow and earlier tools, and it's a hole we don't want to get into. So we do rely on containerization. You should, as a user, and there are examples, and we have even a template Git repo that gets you started with the right Docker files and so on to containerize your code with the pip requirements you need for your task or workflow or multiple of them. And this is what we invoke, right? So you can have tasks that are backed by different containers or the same container. So they can have different native dependencies, different pip requirements, all of that, right? And yeah, so containerization is the solution we found. There are tasks that I must say that do not need any dependencies or any containers, right? Example of that is SQL. You just need the SQL query. People have like love-hate relationship with SQL, right? Some people are like, all SQL, let's do everything in SQL. Some others, it's like, this is a nightmare to maintain, all strings, it's just weird. I guess that's really somewhere in between. But SQL is one of those tools where you just declare the string of what you want to do. It's this why it's a high-level language, and then the engine takes care of like executing it. So in that case, you don't need a container, right? And you don't need the requirements either. And Flyte supports that fully as well. Thank you, Faraz. Andrew, yes, TT, but in the example you showed does not show the Docker image used for each task. Yes, okay, so let me reshare my screen here. So yeah, in the UI here, there are two tasks that ran. There's this tab that we did not look at, it's called tasks, and this tells you how the system views this task. So when I was talking about the registration process and telling the backend about the structure of the task and so on, this is what I was referring to. This JSON blob has all the information Flyte needs to statically compile graphs and to know what to run for a particular task. It has a task, section, an interface section that describes the input types and output types in protobuf as well. And then it has this part, it's called the container section, where it describes the container and the command to run. The actual image is here, right? So this is an image I built earlier called house price prediction. So you have the image, you have the command to run, and then we know how to do how to tie the two. In this example, yes, both of them use the same container, but this is just to show you that they don't have to, right? The container is specific to a task. You can have another task that's using completely different container, and it should work just as well. The examples so Andrew was asking about examples. We have, if you go to docs.flyte.org, this is our main docs website. It has a ton of examples that you can explore, starting from some core concepts in the platform and other, more involved, I would say, examples. There is, here, yes. So you have, the basics. Yeah, you can go to just how do I start resolving a task and what a task is and so on. All of these examples are backed by the same Flyte's next repo I was borrowing code from. But to CT's question, I believe, how do you run multiple containers? Again, there is an example for that. It shows you, it goes through what to expect and how do you declare them. And if you go to the actual code, I think it should be linked here. Yeah, I think, okay. Gives you a way to download, but not, not see the actual code. But yeah, so it's the code for this is here. It's multi-image. Right, so this has both the documentation that we were just looking at, as well as the code for how do you do this for different images. I can post the link. Where are we? Here. I don't know if that answers your question, TT. Andrew, was I talking about distributed? Yes, distributed training, you said. So let's look at, I believe it's integrations, native plugins, external service plugins. Pandera, Papermill. Let's see, is it in case studies? GBoost. Hold on. Yeah, I knew there was distributed. Yeah, so this is an example of a SageMaker PyTorch distributed training. Let's see where the workflow runs on MNIST dataset. And yeah, this is what you essentially have to do. You say, well, it's a task. Again, it's a function that takes the hyperparameters and returns the model. And this is what you need to add to tell us that this should run on as a SageMaker training job. There are, the specification for the settings specific to SageMaker, some information about the algorithm that runs and so on, and the machine it should run on and so on. And then you can use it just like any other task. You can take the output from this, pass it to the next task, and so on. We need that. Would help. Let's see. I think there is Tensor. Oh, no. I thought I saw a TensorFlow demo as well, but yeah. So the plugins are all checked into the system. To TensorFlow, KF TensorFlow. This is the where the plugin is, and all it does is declare how when you write the task and the configuration for it and so on, how many workers you need and so on, right? You all of these declarations, and then how do you serialize this? The actual logic. So this is all somebody had to write in Flyte to support a TensorFlow distributed, but the actual logic all lives in the as a backend plugin written in Go. Right here. So it's a little bit more involved, but not that much more, right? It creates CRDs and monitors CRDs and so on. But this is really all they had to write. Now we have TensorFlow distributed support. Going back to questions. Yeah. So yeah, the doc site has a ton of other examples for you to look at. I think we are running up against time. 2 more minutes. We may be time for one more question, but I will love to thank all of you for attending, for asking questions, and for your interest. You can check out the doc site or Flyte.org for joining our Slack channel. Try out Flyte and please give us feedback. We have a very helpful community. We have the core team would love to answer any of your questions, but all the ton of users that have been using Flyte over the past couple of years are super helpful, and they will jump in even before we can to help you out. So get started, give it a shot, and let us know if you have any feedback or if you have any issues. Join Slack. I will show that, and with it, if you go to Flyte.org, is our homepage, and also marketing page. And if you click on this top link, community, we'll ask you to enter your email and so on, and you get a Slack invite right away. Documentation is here. We have we're building up the muscle for blogs. There are a few here about the integrations and some of the features on specific features or concepts in Flyte. Yeah, and would love to hear from you. We have a community sync up every Tuesday at every other Tuesday. There's this one coming Tuesday at 9 a.m. PST. I would love to see you all there, and we'll share your experience with everyone else. Let me stop sharing, and I will end here. Thank you so much.